BYD, the company that most mainstream automotive media still treats like a footnote, has quietly pulled off one of the most impressive engineering and manufacturing stories, and I think nobody expected that. While everyone was busy arguing about Tesla's valuation or counting Toyota's Prius sales, BYD was building factories the size of small cities, developing hybrid engines that are breaking thermal efficiency records, and locking in a supply chain so tight that their competitors are going to need years just to understand how it works, let alone copy it. Most people still do not know the details, so let me walk you through it. The factories are not what you think. People hear Chinese car factory, and they picture something, well, basic. I need you to completely throw that image away. What BYD has built in cities like Zhengzhou, Shenzhen, and Changsha is a whole different category of industrial operation. Take Zhengzhou. Her music, that facility is by most accounts physically larger than a Tesla gigafactory, and it is not just big for the sake of being big. Automation levels inside are reported around 97%. That means for every 100 steps on the assembly line, roughly 97 of them are handled by machines. Robotic arms lifting engine blocks, fitting battery packs, running wiring, placing every component in the exact same position every single time. A new car rolls off that line every 30 to 60 seconds, day and night. Do the math on that. Then there is Ge, which is where BYD's roots actually are. That is the city where they built their first manufacturing base going back to 2003. Today, the Xine plant runs at a capacity of around 900,000 vehicles per year, producing complete hybrid systems for SUVs and sedans. Hefei is newer but expanding fast. Changsha has a reputation for some of the tightest quality control in the network, and overseeing the powertrain side of all of this is a BYD subsidiary called FinDreams Powertrain, which specifically handles engine production, motor winding, gearbox assembly, and the integration of the full hybrid system. Now here is the strategic piece that I find most interesting. BYD does not buy engines from one supplier and batteries from another and motors from a third party. They make everything themselves. Raw material comes in, finished powertrain goes out under one organizational roof. That is vertical integration at a scale that almost no other automaker in the world has achieved. Toyota is close in some areas, but even Toyota relies on outside suppliers for critical components in ways that BYD simply does not. What that means practically is lower costs, near total quality control, and zero exposure to the supply chain disruptions that crippled almost every other automaker during and after the pandemic. It also means when BYD wants to scale up production, they do not need to convince a supplier to build a new facility, they just build another line, the engine that should make Toyota nervous. Let me talk about the actual hardware. Fasten your seatbelts. The heart of BYD's hybrid system is a 1.5-liter engine called the Xiaoyun. In its earlier form, it achieved a thermal efficiency of 43%. For reference, most production petrol engines in the world sit somewhere between 35% and 40%. Getting to 43% was already a statement. But then BYD launched F-Generation DM technology in 2024, and the updated engine hit 46.26% thermal efficiency. BYD's own chairman Wang called it the highest in the world at the launch event in Shan, and based on everything I have seen, that claim holds up. To put 46% in perspective, getting 1 extra percentage point of thermal efficiency at this level is considered hard engineering. The gains require higher compression ratios, more precise fuel injection, smarter thermal management to reduce heat loss, and tight control over combustion dynamics. It is not a software update. It is serious mechanical and thermodynamic engineering work. The electric motor in the system is rated at 97.5% efficiency, which is frankly close to the theoretical ceiling for electric motors, so you have a petrol engine that wastes remarkably little fuel paired with an electric motor that wastes almost no electricity. That combination is why the real-world fuel consumption numbers are so competitive. Making this engine is not a simple process. It starts with casting and forging, where aluminum and steel alloys get shaped into the basic engine block under heat and pressure. Then, CNC machining handles the precision work, boring cylinders, smoothing surfaces, cutting oil channels, because a hybrid engine has to synchronize with an electric motor in real time, and mechanical tolerances matter a lot here. After that comes full component assembly: pistons, crankshaft, camshaft, her music valves, timing chain, cooling jackets, all fitted in sequence by a mix of robotic systems and human workers. Then the ES unit gets built on a separate line. EHS stands for Electric Hybrid System, and it is essentially a housing that contains both the drive motor and the generator motor in one compact package. Once that is ready, it gets mated to the engine, combined with a reducer gearbox, an inverter, and a controller. The blade battery pack comes from its own production line, passes safety testing, and gets electrically connected to the powertrain with a battery management system installed to handle thermal protection and charge regulation. Before any of it ships, the complete powertrain goes through bench testing at multiple RPM ranges, durability runs, vibration analysis, emissions checks, and full electrical testing of the EHS unit. Anything that fails gets pulled for rework. And because BYD uses digital twin technology, meaning virtual models of the actual machines running simulations before production even begins, a lot of potential failure points get caught before they ever become real problems. Why DMI changes the conversation about hybrids. Now, I want to explain the DMI architecture itself, because I think it is the single most misunderstood part of this whole story. Most people, when they hear hybrid, think of how Toyota has done it for 20 years. Engine drives the wheels, motor helps when it can, small battery, limited electric only range. The engine cycles on and off a lot in city traffic. BYD's DMI system uses a different approach. The electric motor is the primary driver. In everyday city conditions with a charged battery, you are running on electricity, silent, zero vibration, instant torque off the line. You can go 80 to 100 km in a typical DMI model without touching the engine. In the latest DM 5.0 generation, some models push that to 115 km of pure electric range. When the battery drops, the engine turns on, but here is the key part. It does not drive the wheels directly. It runs the generator. The generator produces electricity. That electricity either feeds the motor or tops up the battery. And because the engine is only doing that one job, it can run at its single most efficient RPM the entire time. No variation, no wasted energy fighting road conditions. That is a smart approach to the thermodynamic problem of hybrid powertrains. For situations where you need everything, hard acceleration, overtaking on the highway, a steep climb with weight in the car, a parallel mode kicks in where both the engine and motor push the wheels at the same time. It does not feel like a mode switch. It just feels like the car digs in when you ask it to. The combined range on a full tank plus full battery in the DM5 generation reaches 100 to 3 times according to BYD. What a conventional petrol vehicle can do. And fuel consumption when the battery is depleted sits at 2.6 L per 100 cars, down from 2.9 in the previous generation after BYD pushed a further update through to the DM5 platform. Insane numbers, really. The scale of this thing is the real story. Here is what ties all of it together. BYD launched the world's first mass-produced plug-in hybrid back in 2008. By 2026, cumulative PHV production has passed 7.7 million vehicles and the rate has not been steady. It has been a 25 BYD produced and sold more than 4.6 million new energy vehicles in total. Hybrids have a massive share of that, and in several individual months, hybrid sales actually overtook pure EV sales within BYD's own lineup. That is not a small data point. It tells you that even in China, where EV infrastructure is more developed than almost anywhere else, a huge portion of buyers are choosing the flexibility of a good hybrid over the purity of a full EV. Because of vertical integration, scaling that production does not require renegotiating supply contracts or waiting on outside partners to build capacity. BYD adds lines, production goes up. It is a compounding structural advantage that grows more significant the further ahead they get. What this means for Toyota, and Tesla. Toyota built the hybrid category and deserves enormous credit for it. The Prius architecture is proven reliable and efficient, but it is also, honestly, getting old in its assumptions. The Atkinson cycle engine, the smaller battery, the engine-first logic. These are design choices made in the late 1990s. BYD is a 20s answer to the same problem, but with innovative solution. For Tata clears throat and other emerging market manufacturers, BYD is actively building assembly plants in Brazil, Thailand, Uzbekistan, and is constructing facilities in Hungary and Turkey. In Brazil, they are even adapting engines for flex fuel compatibility, which shows they are thinking about local market realities, rather than just exporting a China-spec product. Music, when BYD gets its local manufacturing cost structure sorted in these regions, the price gap with domestic competitors is going to shrink fast. For Tesla, her music, the challenge is more philosophical. Tesla's entire identity is built on the idea that a full EV is the only serious answer. BYD is demonstrating at scale with millions of real customers that a well-engineered electric-first hybrid delivers most of the EV experience while eliminating range anxiety entirely. In markets where charging infrastructure is still years away from being adequate, that is not a compromise. That is actually the better product for most people's lives right now. Where this goes next, there are real challenges worth naming. Battery material prices, lithium especially, remain volatile and globally exposed to supply disruptions and political pressure. Western tariffs are creating genuine headwinds for direct market entry, particularly in Europe and North America, and the competition is not standing still. Every major automaker has engineers working on this problem right now, but I keep coming back to the fact that BYD has 5 generations of DMI development behind them, their own materials sourcing, their own manufacturing ecosystem, and a product that is already refined through millions of real-world kilometers of customer use. The next generation of the platform is already in development with further range and efficiency improvements. Over-the-air updates mean cars already sold keep getting better, and the manufacturing technology, AI quality monitoring, real-time cloud production data, digital twin simulation keeps tightening. I think BYD's hybrid system is one of those technologies that people underestimate right up until the moment they cannot ignore it anymore. The factories are real, the engineering is real, the numbers are real, and the disruption is already well underway.